Okay, pre-cal students, in this video we are going to learn what reference angles are, and we're going to learn how to find them. So your heading today will be reference angles. Go ahead and copy this in your notes if you would, please. And then also go ahead and copy the date here with your heading. Your heading today is reference angles. Please copy that down and please include today's date. Let's go ahead and continue on. Now, in a future video, you will see how amazingly important reference angles are. If you can't find reference angles, you will be very lost in trigonometry. So please take really good notes during this video. Copy this in your notes if you would, please. A reference angle is the positive acute angle that is formed between the terminal side of an angle and the x-axis. Let me read that again. A reference angle is the positive acute angle that is formed between the terminal side of an angle and the x-axis. Now, that's a really good thorough definition of what a reference angle is. However, a picture always helps. So here's an example of what a reference angle is, okay? Let's say that I ask you to find the reference angle for 170 degrees, okay? Well, let's go ahead and draw 170 degrees. So we would draw it about right there, and then draw our terminal side right here. And that's not a very good drawing, but you get the idea. There we go. So there's 170 degrees. Does everybody see that? Okay, it's pretty simple to do. So we have drawn an angle for 170 degrees. Now I want you to find the reference angle for 170 degrees. Well, the definition says it is the acute angle formed by the terminal side. Here's the terminal side. And the x-axis. Here's the x-axis. So there, I highlight the angle. So that angle right there is the reference angle for 170 degrees. And that reference angle would be what? 10 degrees. Because we know if we start here and go all the way around, that's 180 degrees. So the reference angle for 170 degrees is 10. Let's try another one real quick. What if I said find the reference angle for 235 degrees? 235 degrees. Okay, well, let's go 180, and then we go 55 more degrees, so about right there, and then draw our angle. There we go. So from here to here is 235 degrees. Now I want you to find the reference angle. Well, I just showed you how to do it. You want the acute angle that is formed by the terminal side. Well, the terminal side, don't forget, is the ending part of your angle. So here's your terminal side, and here's your x-axis. So you're looking for that angle right there, formed by those two dark black shaded rays, okay? And so think about it. If from here to here is 180 degrees, then that means this right here has to be 55 degrees. Think about it. If I take 235 degrees and I subtract out 180, I'm left with 55 degrees. And so this little angle right here, I'm going to highlight it in green, this little angle right here has to be 55 degrees. So the reference angle for 235 degrees is 55 degrees. So that's an example of what this definition is saying right here. Okay, now take some really good notes, please. We're going to do 4 of these together, then you'll do 2 on your own, and then we'll be finished with the video. Alright, so here we go. I would like you to find the reference angle for 125 degrees. So we're going to estimate 125 degrees. We know from here to here is 90, and then 35 degrees more would be about right here. And so we're going to go ahead and draw our angle, and this is 135 degrees. Now the reference angle, of course, is the angle formed by your terminal side and your x-axis. So think about it. If from here all the way to here is 180 and I only went 135 degrees, then the remaining part right here has to be 45 degrees, because 135 plus 45 more would be 180. So the reference angle for 100, you know what, and I made a mistake. I apologize, guys, if you will allow me to be imperfect. Let's just go ahead and change this example to 135, and that's my fault. Sorry about that. That's the easiest way to fix the problem. So we're going to pretend the original problem said 135 degrees, and so I drew my 135 degrees, and the reference angle has to be 45 degrees. Okay? All right, let's try another one here. Let's try negative 5 pi over 6. Now we're dealing with radians, so I think it would be very helpful to label our angles here in radians using pi. So 90 degrees is pi over 2. 180 is pi. So here's a half, then a half more for a whole, then a half more. So here I have 1.5 pi, and of course the right way to write that is 3 pi over 2. And then if we go another half pi, that's going to be a full rotation all the way around, and that's going to be 2 pi. Okay? Now, notice we're going negative 5 pi over 6. So let's think this through, guys. Be very careful. We know from, and actually, since I'm going to go negative and go down this way, from here to here is 90, or pi over 2. Now, don't forget, pi over 2 really just means 1/2 pi. Okay? So from here to here, I've got a 1/2 pi. And the negative sign here, don't forget, students, the negative sign just means direction. Instead of going 5 pi over 6 this direction, I'm going 5 pi over 6 this direction. Okay? So here's 1/2 pi, and then I continue going. 5 pi 6, of course, is the same thing as 5/6 pi. That's not quite 1 whole pi, so we're going to stop about right here, and that's good enough. We'll just kind of stop right there. We're just estimating. It's no big deal, and we'll go ahead and draw our angle. Okay? There we go. So this angle right here is 5 pi over 6. Now I didn't worry about the negative sign because we've already gone the proper direction, so I'm not worried about the negative sign. Now think about it, students. Come on, use your fraction ability. This is 1 whole pi if I start from here and go all the way to here, and I stopped right here. I went 5/6 of a pi, so I've got to go 1/6 more, or in other words 1/6 pi, or in other words pi over 6. And please don't put 1/6 pi on a test or a quiz. I would take points off for that. Okay? The correct way to write it is pi over 6. So the reference angle for negative 5 pi over 6 would be pi over 6. Okay? Now, and by the way, your reference angle will always be positive. It's not going to be negative. Okay, let's try another one. Now we want to find the reference angle for 5. Now look, we better label our angles a little differently. Does it say 5 degrees? No, it does not. So it's 5 radians. So remember, from here to here is pi over 2. Well, that means 3.14 divided by 2, which would be 1.57. And if I rotate 180 degrees, that's pi, or in other words, 3.14. Do you see how I'm not using pi as I'm marking the coordinate plane here? The reason I'm not using pi is this radian measurement here that I'm circling 5, it's not written in terms of pi. So I don't want pi, I want decimals. Now we come over here and we would have 3 pi over 2, which really means 3 times 3.14 and then divided by 2. And you'll get 4.71. Okay? So this is 4.71. And then of course if you go all the way around, that's 2 pi, and 2 times pi is 6.28. Now do you not see what I did? Doesn't that make it really helpful? You're going to rotate around 5, and now that I've got these these different quadrants marked off with decimals, you can see where to go. From here to here is 1.57, so I keep going to here, that's 3.14. I keep going to here, that's 4.71. Okay, and so I'm going to, and really I don't care if it's drawn perfectly to scale. I'm just going to go a little further here, that's good enough, and just draw my angle. Because I know 5 radians has to be past 4.71, but it has to be less than 6.28. So I'm going to stop right here, and I'm going to label that angle 5 radians. Now students, think about it. If I want to find the reference angle, it's always the angle formed by the terminal side and the x-axis. So I'm looking for this angle right here. So this is not too bad. If I would have gone all the way around, it would be 6.28, but I didn't. I stopped at 5. So the remaining part, if you take 6.28 minus 5, this little angle right here, has to be 1.28. Think about it. From here to here is 5, and then you go 1.28 more, and you have 6.28. So the reference angle for 5 would be 1.28. Okay? All right, last one, and I'll give you 2 to try on your own. I want you to find the reference angle for 29 degrees. Well, this will be pretty easy. We're going to rotate up 29 degrees. We're going to draw our angle, and we're going to label this angle 29 degrees. There we go. That's easy enough. Now, the reference angle is the angle formed with your terminal side and the x-axis. And what is that angle right there? 29 degrees. And so the reference angle for 29 degrees is just 29 degrees. Pretty simple. Okay? Now, I would like you to try these 2 on your own. I want you to pause the video and find the reference angle for both of the 2 angles given below. When you're done, then play the video to check your answers. So go ahead and do that now at this time. Okay, let's go ahead and find the reference angle for the first one here. And let's see how you did. Okay, we're going to go negative 7 pi over 5. Now remember, that's the same thing as negative 1 2/5 pi. That really helps you if you'll think of that, okay? So we know we're going negative, so we know we're going to go down. Well, that's a half a pi. And then we're going to continue to here. That's a whole pi. So here was a half a pi. Here was a whole pi. And now I've got to go 2/4 more, okay? Now think about it. 2/5 is 0.4. So we're not quite going to be to 3 pi over 2, or in other words, 1 1/2 pi, okay? If you'll use your calculator, 1 2/5 is 1.4, okay? 1 1/2 is 1.5. So we're not quite to 1.5, so we'll stop about right there. That's good enough. And we'll go ahead and draw our angle, or our terminal side, And so the angle that went from here all the way to here was negative 7 pi over 5. Now think about that, students. Come on. So we went 1 2/5 pi, and we left this little space right here. Now, in order to find the reference angle, it's always going to be the angle between the terminal side right here and your x-axis right here. So we want this little angle right here, that little angle right there. Well, think about it. From here to here is 1 pi. And we went 1 2/5. So from here to here is 1. This little bit left right here has to be 2/5 pi. Or the best way to write it is 2 pi over 5. So there is your reference angle for negative 7 pi over 5. Let's try one more and we're finished, okay? Notice in this problem here, it's not degrees. There's no degree symbol, so we're dealing with radians. So real quick, I'm going to write down what I had before the last time. I'm going to put, let's see, 1.57 here, and then 3.14 here, and I think it was 4.71 here, if I remember correctly. And then over here 6.28. Now we're going to move 3.7 radians. 3.7 is larger than 3.14, but is smaller than 4.71. I really don't care if I draw my angle to scale. I'm just going to stop right here and draw a terminal side, and there we go. So the angle that goes from here to here is 3.7 radians. Now, the reference angle is the angle formed with the terminal side and the x-axis, so this angle right here. So think about it. If from here to here is 3.14, and I went all the way around to here, which is 3.7, I'm simply going to take 3.7 and subtract 3.14. Okay? And if I do that correctly, I'm going to get 0.56. Okay? So this little space right here is 0.56 radians. Okay? So the reference angle for 3.7 radians is 0.56 radians. All right? This is a pretty short video. However, don't miss this, students. From now on, whenever I say to find the reference angle, I'm not going to teach you this again, and you need to be able to do it quickly and accurately. Draw your coordinate plane, draw your angle, and then find the reference angle. If you cannot do this, you will be lost, actually very badly, in the future trigonometry we're going to do, because you have to be able to find your reference angles very, very quickly. Okay? Call or email if you have any questions.